This question is a follow-up part of the previous question that I discussed with you. Basically, it's the same story. So if you see over here, we once again have 251 observations. So that means lowercase n is equal to 251. Earnings is the dependent variable, and we have three independent variables: gender, education, and age. And we are given three models over here, and this is the output corresponding to these three models. So now let's see what is it that they are asking us to find in this question. So we have to do an F-test in this question, and we have to test whether the estimates of beta 4 and beta 5 are jointly equal to 0, and which is the correct F statistic. So basically, first of all, you need to note that we have to do testing on beta 4 and beta 5. So the null hypothesis is going to be that beta 4 is equal to 0 and beta 5 is equal to 0. You can also write this as beta 4 equal to beta 5 equal to 0. Okay, so this is how a joint null hypothesis is written, and the alternative is going to be that at least one of them is not equal to 0. So the alternative hypothesis is actually going to have multiple cases. So we can write this statement, and this statement will take into account the multiple cases that the alternative hypothesis is going to have. Okay, so this is your null and this is your alternative. Now, if you want to work with the F-test, you should know that there is going to be one unrestricted model and one restricted model. So we know over here that beta 4 and beta 5 is there in this regression number 3. Okay, so this is going to be our unrestricted model. So I'm writing UR for the unrestricted. So model number 3 is going to be the unrestricted model. Now, what's going to be the restricted model? Well, to get the restricted model, we have to do a very simple thing. So whatever restrictions you have in the null hypothesis, you put these restrictions in the unrestricted model. Okay, so let's do it. So in the unrestricted model, if I put the restrictions, so basically what we are going to do is that instead of beta 4 and beta 5, I'm going to put 0. So earnings is equal to beta 0 plus beta 1 age plus beta 2 age square plus beta 3 female plus, instead of beta 4, I have to put 0. So plus 0 times high school, and instead of beta 5 also I have to put 0. So 0 times college plus the error term. So this goes away and this goes away. And if you see, you are just left with what we have in model number 2. So basically, what is it that we are getting from here? That the model number 3 is going to be your unrestricted model, and the model number 2 is going to be your restricted model. So I'm using UR for the unrestricted and I'm using R for the restricted. I hope this much is clear. Now we have to use the F formula. So the F formula that we have is R square of the unrestricted model minus the R square of the restricted model divided by the number of restrictions. Okay, I'm deliberately not using any notations over here because notations may lead to some confusion. So I'm just going to write the complete thing, that it is R square of the unrestricted model minus the R square of the restricted model divided by the number of restrictions. Now you can use whatever notations you want to use for the number of restrictions. I've just written the complete statement. This is divided by 1 minus R square of the unrestricted model divided by degrees of freedom. So DOF means degrees of freedom of the unrestricted model. Now let me explain this. So first of all, we need to know what is the R square of the unrestricted model. Well, we know that the unrestricted model is model number 3, and it's given over here that the R square of model number 3 is 0.306. Note that in the F formula, you have to work with R square and not adjusted R square. So these adjusted R square values are given over here just to confuse you. So do not take a look at these values. Okay, these are of no use. So the R square of the unrestricted model, that's your model number 3, it is equal to 0.306. So this is 0.306 minus What is the R square of the restricted model? Well, your restricted model is model number 2. So the R square of model number 2 is 0.105. Okay, this is 0.105. Now, what is the number of restrictions? How do we find it? Well, it's a very simple thing. To calculate your number of restrictions, you just have to count the number of equal to signs in your null hypothesis. Let me repeat this again. The number of restrictions are the number of equal to signs that you see under the null hypothesis. So let's take a look at our null hypothesis and let's see how many equal to signs we have under our null hypothesis. So this is equal to sign number 1 and this is equal to sign number 2. It doesn't matter whether you write your null hypothesis in this manner or in this manner. The number of equal to signs are going to remain same, which in this case is equal to 2. Okay, so your number of restrictions is equal to the number of equal to signs that are there under the null hypothesis. In our case, we have 2 equal to signs, so you can just write 2 over here. Now this is divided by 1 minus. Now for the denominator, you need to note this thing that the entire denominator is for the unrestricted model. So over here, it's the R square of the unrestricted model. And this is the degrees of freedom of the unrestricted model, okay? So there is no rule of the restricted model in the denominator, right? So this is 1 minus R square of the unrestricted model, which is 1 minus 0.306 divided by degrees of freedom of the unrestricted model. Now, what do we mean by degrees of freedom of unrestricted model? How do we find it? Well, degrees of freedom is defined as n minus the total number of parameters. Once again, I'm trying to avoid any notations over here. Okay, so you can use whatever notations you're comfortable with. I'm just going to write the complete thing. The complete thing is that the degrees of freedom are going to be n, which is your sample size, right? Minus the total number of parameters. What do we mean by total number of parameters? Well, these betas are your parameters, okay? So what's going to be the degrees of freedom of your unrestricted model? What's your n? Your n is 251. So this is 251 minus the total number of parameters. Let's count the total number of betas in the model number 3. So this is 1, 2, 3, 4, 5, and 6. Note that you have to count all the betas, even the intercept one. Okay, this is also one mistake that many students do. They do not count the intercept. They just count beta 1, beta 2, beta 3, beta 4, beta 5, and then they end up writing 251 minus 5. No, you have to count the total parameters, which also includes your intercept parameter. So your total parameters over here are actually equal to 6. So this is 251 minus 6, which is equal to 245. So you're going to put 245 over here. And when you solve this, you will get that F is equal to 35.47. That means your right answer is part number D.